Like with parallel lines, we can also determine if the lines are perpendicular by looking at their slopes. And in order to do that, we take the product of their slopes, and if the product of their slopes equals a -1, then we know those lines are perpendicular. So for example, in this graph, perpendicular looks like I have these two orange lines. They meet at a right angle, which is a definition also of what perpendicular lines look like. And also that their slopes, the product of their slopes equals -1. Okay, you said a whole bunch of words there, Willie, but it wasn't making sense to me. So let's look at an example and you get a sense of what's happening. So let's look at the slopes of these two lines. The slope of A, or of my A set of points, and that's y2 minus y1, so 6 minus a 9, 6 minus a -9, and 3 minus a -6, and that equals 15 over 9. And I can reduce that down. 3 goes into both of them, so that's the same slope as 5/3. Slope of 5/3. Yep. Slope of the second set of lines, y2 minus y1, so 1 minus a -8, all over x2 is my x1 is a -5 minus 10. I get a slope of 9 over -15. And that reduces down to -3/5. So these two lines are perpendicular if the product of their slopes equals a -1. Product means multiplication, so this slope times that slope. 5/3 times a -3/5 equals -15 over 15, which equals a -1. So those slopes do indeed, when multiplied to each other, equal a -1. And because it equals a -1, that tells me those two slopes are perpendicular. And you can kind of get the sense of that. If one slope has a rise of 5 over 3 and the other one has a negative rise of 3 over 5, that tells me that they are going in opposite directions equally fast or are perpendicular.